हाँ, क्या बोले कि तुमको मेरे को प्यार करने के लिए नहीं आना है मेरे पास। अच्छा ठीक है। Understood that. I did. अगर करना ही होता तो इतना भी बोल देती कि हाँ। उसमें हाँ बोलने में क्या जा रहा था तुम्हारा। तेरे को क्लेरिफाई करना है। हाँ तो वो तो सब क्लेरिफाई करना है ना। हम क्यों डिस्टर्ब करेंगे तुमको। हम तुमको बोले इज्जत से कि
Good morning, sir. Sir? Sir, can you hear me?
I'm here, yeah. Let everyone join, then we'll start the meeting.
Actually, I'll be the only one attending the class.
Okay, so only one student here for today.
Yes, sir.
Rest all of them.
Sir?
Where did all of them go?
Sir, Nitish went out, sir. Sankalp is in Delhi, and Tarun is traveling to his native place.
Okay. Okay, so only one student. Okay,
Tarun and
let us do.
Sankalp won't attend.
Hello, am I audible?
Yes, sir. I don't know why, but I'm not able to access the meeting in my computer. It says the meeting has been started.
Okay.
Second, sir.
Can you see my screen?
Sir.
Is it fine with you?
Yes, sir.
Okay, just give me a minute. Yeah, we have to start today with I guess motion in one dimension, right?
Sir, aren't we done with that?
That chapter we have done. Any doubts
Sir,
there?
yes.
Have you solved the questions?
No, sir. We've done with the assignment also.
But also all question done.
Yes, sir.
Okay. Who is this? Yeah. Okay, you have joined with all of them. Yeah.
Yes, I joined with the computer.
Yeah. Oh, that's fine. So we'll be starting today with motion in one dimension, and we'll be doing with some examples, theory first, and then problems, right? As we did in the previous
Yes,
chapter. So if your friends come, we'll be like discussing in brief for once again. Okay, am I clearly audible?
yes, sir.
Okay. So see, motion in one dimension. We'll be starting with two. See, whole of the physics is divided into two quantities. Whole physics is divided into two quantities. One is scalars, and another one is vectors. Scalar is those quantities which require only magnitude, and these are those quantities.
That need magnitude and direction.
Yeah, very good. Which requires magnitude as well as direction. Okay. Like, what was the use of this? What was the use of dividing the physics into vectors and scalars? See, like let us say that you are standing here, you are K, you are standing here, and you have two of your friends nearby. This is A and this is B, right? So now you are blindfolded. You are blindfolded, okay? And A is asking you to find B. You have to find B, right? and A will tell you where is B. So if A says that you have to move 5 meters to catch B, will you be able to catch B?
No, sir.
Why? Because you don't know where
Because
to move
I'm
5 meters. 5 meters
blindfolded.
here, where? Now, if A says that you have to move 5 meters in the east and B is standing in the east, then will you be able to catch B?
Yes, sir.
Right? So that is the thing. You need some directions. You need some directions to specify the perfect location of a person or place or something. Okay. So you need directions. That's why the whole physics is divided into vectors and scalars. Right? So general quantities
Yes.
like mass, we don't require any direction there. Mass is there. Then time, density, volume, speed. These are scalar quantities. Here,
Yes.
velocity. Speed and velocity are two different things. I'll let you know after this. Velocity, acceleration,
Yes.
displacement, displacement, more force. All these are vector quantity. Okay. So you understood till here?
So what about time?
Time is scalar quantity. We don't require any kind of direction to specify time, right?
Yes.
So write it down, the first page, and then we'll be moving forward.
And
So vectors are generally represented by this sign, some vector A and this an arrow over the top. Okay, these are the representation of vectors. Understood till here?
yes, sir.
Okay. Now we'll be moving deep into this chapter. This motion in one dimension is the main topic. Okay. So we'll be dealing with some basic
Yes.
concepts or basic terms that are there in this rest and motion topic. Okay. Motion in one dimensions where we have the topics like rest, motion, distance, displacement, velocity, speed, acceleration, like that. Okay. So
Acceleration.
first we'll be doing rest and motion. What is rest? First, if I just define rest, a body is said to be at rest.
It is stationary.
Said to be at rest
If it is
when
stationary.
it does not change its position position with reference to
That's good time.
its immediate surrounding, whatever is there, immediate surrounding. Immediate surrounding. And what is motion? A body is said to be in motion if it changes its position with respect to immediate
Immediate.
surrounding. Immediate surrounding means whatever is there nearby, right? Understood? So see, what is rest and motion? For example, if a tree is there, okay, and there's a road nearby, and there's a car on the road,
Yes, sir.
and you are standing here by the tree, and there's one more man, that is me, watching you and the car. So after some time, let us say I saw the watch at this time, and it was 9:15, let us say, and after 15 minutes, that is at 9:30, the car was here.
Yes, sir.
So sometimes the car was here initially.
I thought if so the first the car was at sea, right?
First the car was at sea, and now the sea car is here. Okay, at 9:15 the car was here, and at 9:30 the car is here. But in both, in between this time, A was standing there by the tree only, at the certain distance from there. So the car changed its position with respect to the immediate surrounding, but the man did not change. So man is said to be at rest, and the car is said to be in motion. Yeah, but with respect to this man, let us say this is D, or let us say this is um,
So if I'm sitting
with
inside
respect
a
to this
car,
man.
car is an immediate surrounding,
Pardon?
right? Sir, if
Pardon?
I'm sitting inside a car, if I'm
Uh,
sitting inside a car, the car is my immediate surrounding. So I'm at rest, even if the car is moving.
Understood. So first you
Yes,
understood this lines and the rest in motion topic.
yes, sir.
Okay, so write it down and draw this figure also.
Yes, I'm almost. Done, sir.
Rest in
Oh,
motion, you
done.
understood?
Yes, sir.
Okay. Okay, let us go something into deep, more inside this. Yeah. So see here, rest and motion. If I say that they are relative term, so that won't be wrong. For example, let us assume that this is a bus. This is a bus. Or let us move on to the next page. This is a bus. And you and your friend are sitting at the window side. You're wrong way, and your friend is like, let us say that is A. And there is one more boy standing outside and looking at the bus. Okay,
Yes,
understood the
sir.
situation? Now, if you and your friend inside the bus is sleeping, okay, the bus is moving. So will you, if on asking that state the motion of that your friend inside the bus, so will you say he's in motion or he's at rest?
Sir, the boy outside.
So inside with you sleeping,
Oh, he's at rest, sir.
he's at rest. That you'll tell. And for the man that is standing outside,
He's also at rest.
no, the man who's standing outside. See, when you observe things now, you have to be the standard object when you observe things.
Oh, then
So your
the
motion will
man is
be
moving.
so exactly. When you are the
Surrounding is
observer, now
moving,
then
the
the
bus
motion
is
will be.
standing.
For example, I tell a simple example. When you are at the bus, do you say that you passed the man, or you say that the man passed by?
The man passed by.
Because you talk about with your reference, right?
Yes, sir.
Are you understanding me? So whenever you observe, whoever is the observer, his velocity, his displacement, his time, is taken as the standard. Okay, that with reference to that we consider the things. So if the man here is moving right and he is the observer, that means this man is moving to the left. Okay, like that it goes. Got it?
Yes, sir.
So now this man, this A is at rest with reference to U, and this A is in motion with respect to O. So like a single man, okay, is at rest with reference to something and is in motion with respect to others, right?
Yes, sir.
So that is why we said that the motion, rest, and motion are relative terms. For example, let us say they both, all of them are at Earth, all of them are at Earth, and there is a man astronaut, okay, outside the space. So according to him, this man on the ground will also be in motion because Earth is rotating,
Yes,
isn't
sir.
it? So that is why it is said that the rest and motion are relative terms. You write it there. Rest and motion are relative terms. Should
Yes.
got it? Yeah.
Done, sir.
Okay. Now we'll be studying about one-dimensional motion. What is one-dimensional motion?
So it's a scalar quantity. It's only one. Oh, no, sir. One
Yeah,
dimension is like uh, drawing on a paper.
kind of.
It only has
When a body
it
moves in
only
a
has
straight
like
line.
one dimension. It only has x dimension.
Yeah, very good. Body moves in a straight line.
Uh,
It is said to be in, or the motion is said to be. Dimensional motion. Sit down.
sorry, your screen sharing is stopped.
What?
Your screen sharing is stopped.
Screen sharing stopped. Share
Yes,
it
sir.
again. Can you see it now?
Screen. Yes, sir.
Yes. Write it down fast.
Done, sir.
Done?
Yes, sir.
Okay. Let us move further. This was motion in one
Yes,
dimension.
sir.
Okay. Yeah. So next thing
Yes,
that
sir.
we have to do is the terms that are related with this. Okay. What we have to see is the terms that are related with. Okay. Now the first of them are distance and displacement. What is distance? What is displacement? Distance is total length of path a body has traveled. Length of path a body has traveled is called distance. The next
Distance.
one is displacement.
Displacement is how much
Yeah.
distance the body has moved from the starting point.
Shortest path. This is said to be the shortest path
from the starting point to where the body is.
Initial and final point. Actual distance. Okay. And if a man goes straight, this will be the displacement. Displacement, and this will be the distance. Understood or not?
Sir? Yes,
Go on.
we get it. Like
Okay,
it's
so
a
write it down.
train going from one place to other place and coming back. Yes, sir.
That is not exactly also distance because even trains takes a curve.
So no, sir. I'm saying like let's say there's a train from Chennai to Mumbai. So and then it comes back to Chennai. Let's say Chennai to Mumbai is 50 kilometers. So the distance the train has traveled is 100 kilometers and displacement is zero because it has come back to Chennai.
Exactly. That's correct. That's correct. Because the initial and final point are same. So no difference is there. That's why displacement zero.
Done, sir.
Okay. Till you're done? Yeah.
Yes.
Yeah. So distance displacement is done.
Yes, sir.
Now we'll see the question. Okay. So for example, if I'll just give you one question. If a man A lives here, okay, this is his house, okay, and this is the stadium where he want to go. This is 5 kilometers here, and then he has to take a left turn to 4 kilometers, or
Yes,
it be
sir.
3 kilometers here, and then take a turn 4 kilometers. You have to find the distance and displacement.
The
Distance and
distance is
displacement.
7 kilometers.
Okay, and displacement.
The distance is 7 kilometers. Displacement, I'm not sure how to find it out. 1 second, sir. I'll try.
That is
Yes,
all
sir.
this. How much?
Yes, I'll try. Just a second,
How much?
1 second.
I'm not able to hear
7
you.
meters, sir. Your centimeters. Now, sir.
Yeah, yeah.
Sir, it's yes, sir. Yeah.
And the displacement.
So 1 second.
Take your time.
I need to draw grid for this.
Pardon?
I need to draw grid for this, sir.
See, if you want to find the displacement, you need to draw a straight line between initial and final point. That is, this is B, this is C. So we need to find AC, and if this is
Yes,
90
sir.
degree, so we have to use Pythagoras theorem. Using Pythagoras
Oh,
theorem,
like form a triangle. Oh, yes, sir. Yes, sir. Oh, my God.
AB square plus
Yes,
BC
sir.
square is equal to AC square.
That's 5
Now tell me the
5
answer.
meters.
Yeah,
5
exactly. That is 5
meters.
meters. 3 square plus 4 square is equal to AC square. AC is equal to 5 meters. Understood?
Yes, sir.
Okay. Now, write it down. We'll see some differences between
Yes,
distance and
sir.
displacement.
I wrote it down. I wrote it down.
Written?
Yes, sir. I wrote it down.
Okay. I'm changing the slide.
Yes, sir. I'm done. I'm done.
Okay. See here. Distance, displacement. Okay. The first point. First point is the difference between distance and displacement. You have to give the definition. It is the length of actual path traveled. Okay. And here in the first point, it is the distance traveled the distance traveled by object
Yes, sir.
in a specified direction. In a specified direction. Okay. Or shortest distance between initial and initial and there.
Final point.
Yeah. Understood. Second point of difference. It is scalar quantity.
Yes,
No
sir.
directions required. Scalar quantity. And this was in vector quantity.
Displacement is a vector.
It's vector quantity. Third point. If it is scalar, it will always be positive. It is always positive. Always positive.
Yes.
It
Sir,
may be
how can
negative.
displacement be negative?
I'll tell you. I'll tell you. I'll tell you. See, in maths, when you talk about something negative, now that means you have that loan or you have that debt. Okay. But in physics, if you talk anything about negative, that means the direction that you have specified, the object is going in the opposite direction. Understood?
So like minus meters east, which is equal to plus 5 meters west.
So like if you take minus 5 meters, that means the 5 is the magnitude and you have to move minus 5 meters. That means the original the direction that you have specified, you have to move opposite to that in order to get minus 5. Understood?
So you can convert it to positive.
Yeah. If you travel on the opposite direction, you'll convert it into positive. Okay.
Okay.
Next we have
Yes.
yeah. It is always either or let us just write either. It is either more than or equal to
Displacement or say
displacement. It is either
displacement.
equal to displacement, so distance. Did not you understand the last term?
Yes, sir.
Understood everything there? Length of actual part traveled,
Yes, sir.
total
Once
distance.
again, right.
The scalar, it is vector. Always positive, maybe negative because it is vector, so directions are required. It is if it is either more than or equal to displacement, it is either less than or equal to displacement. Got it?
Yes, sir. Once again, right.
Write it down.
Yes, sir. So, done, sir.
Done with this?
Yes, sir.
Sure.
Yes, sir. I'm done
You'll
with all.
have to remember it. I'll ask in the next class. Okay.
Sir?
Next thing that we're going to, you'll have to remember this. I'll ask this in the next class.
Yes, sir, sure.
The next thing that you have to do is speed and distance, speed and velocity. Speed and velocity.
Speed is scalar velocity.
Okay. Speed and velocity. So what is speed? It is
It's a
the
scalar quantity that defines distance by
rate
time.
of change of displacement.
Mhm.
Displacement. Rate of change of displacement with respect to time.
Or otherwise,
Called the-
it's distance by time.
Sorry, here it is distance.
So
Because the
distance by
directions are not
time.
specified in speed. Here it is the displacement. Here it is the rate of change of displacement. Displacement with respect to time. Understood or not? So
Sir?
where does the day come like rate come from? Rate is something that is applied in dt. Like if you have anything as dx by dt. So with respect to time, whenever you want to differentiate, so it is always your this term is used. Rate change is used. Understood?
Yes, sir.
So this term is rate change is used whenever you get something like this. Okay. So this is with the velocity. Velocity is the rate of change of displacement with respect to time. Got it?
Yes,
Got
sir.
it?
Got it.
So I can say numerically velocity is rate of change of displacement with respect to time. Got it?
Yes, sir.
Okay. So write it down.
Yes, sir.
Written. Written till here.
Yes, sir. Yes, yes, sir. You can move on.
Sure.
Yes, sir.
Okay. Now we'll be seeing about. Now we'll be seeing about your speed and velocity. We did a little now. So generally, we'll be using the term speed because we'll be assuming that the or velocity may also be used. We'll be assuming that the road is fulfilled in a straight line. The velocity is moving in a straight line. Okay, the car is there that is moving in a straight line. That's why it is said to be velocity and speed are then same. Because if you're moving in a straight line, so you do not need to specify the directions, right?
Yes, sir.
If you're moving in a straight line, you do not need to specify the directions. So velocity or speed. First, let us write speed. Speed. Speed is nothing but distance upon time.
Distance by time.
Got it? Yeah, that is speed. how much distance you covered in what time. Got it?
Yes, sir.
Got it? Yeah. So its unit, yeah. So unit of distance is meter and unit of time is second. So unit meter per second. Even for
Speed is
velocity, it is
meter per
same.
second.
Yeah. The two things are there: uniform speed and non-uniform speed.
Non-uniform speed.
So first of all, what is uniform speed? Okay, a body is said to be in
So
uniform speed.
uniform speed is in equal intervals of time.
Okay, let me rejoin that.
Same distance in equal interval of time.
Okay, sorry. Uniform speed of body is a body is said to be in uniform speed if it covers equal distance in equal interval of time.
Equal interval of time.
Yeah, got it. And similarly, non-uniform speed is just the
Yes.
opposite of it. A body
A body is
is
said
said
to
to
be
be
in non-uniform speed when it travels unequal distance in equal interval of time.
yeah if it travels equal distance in equal interval of time.
Yes.
Interval of time. Understood or not?
Yes,
Okay. So when you travel equal in equal time, we have first hour the body traveled 2 kilometers. In the second hour, the body again traveled 2 kilometers. In the third hour, the body again traveled 2 kilometers. So it is said to be in uniform speed. And on the other case, if the body's speed is changing, like the first hour the body traveled 2 kilometers, in the next hour it traveled 4 kilometers, in the next hour it traveled 0.5 kilometers. So in that case, the speed is changing. So then what you have to do, you have to say like categorize it into non-uniform speed. So there's a difference between uniform and non-uniform speed. Hope you have understood this.
yes, sir.
Okay, so write it down.
Yes. Done, sir.
Okay. So let us stop here because most of your friends are not here. So till here I can revise in a very quickly manner, and that will be easy for me. Hope they'll be back in the
Yes,
next
sir.
class.
Please finish
So
this chapter.
afterward, let us solve some questions. Let us solve some questions.
Yes, sir.
Okay, we have to see the conversion of conversion of kilometer per hour to meter per second also. We'll do this in the next class.
5 by
And we'll
18.
do that in 5 by 18 that you have to see. We have to see that in the next class. Okay, a body covers 120 meter in 2 seconds. In 2 seconds, you have to calculate speed of the train. Calculate the speed of the train.
60 meter per second.
Time it will take to cover 240 meters.
4 seconds, sir.
240 meters.
So it'll take 4 seconds. 4, sir. Answer is 4. Sir, it's 4, sir. I'm done.
Speed I need to check, not the time. The first one you say me. The speed. Calculate the speed of the train. How much speed it is.
60 meter per second.
That is 60
Sir.
meters per second. How did you get that? You have to divide 120 divided by 2. Total distance traveled by total time taken. That is 60 meters per second. And then again we had distance by time is equals to speed, and the speed we had, that is 60. Distance, it was 240 meters. Time we don't know. So time will be 240 by 60. That is 4 seconds. Isn't it? Isn't it?
Yes, sir.
Okay.
Yes.
So till here you have understood everything?
Yes, sir.
Kongwei, did you understand everything till here?
Yes, sir.
Okay. So I think we should end it up here because I need to then teach a lot for them. We are stopping it here. Otherwise, I'll have to teach a lot for them. Okay.
Only 3 more minutes.
Right?
Yes, sir.
Okay. So we'll be ending up here. We'll be meeting in the next class. That is on Wednesday, I guess.
Yes,
Okay
sir.
then. Bye.
Bye, sir.